The topic for today, guys, is to solve inequalities. I'm going to write it in here. Solve inequalities using addition or subtraction. Okay, I'm going to write the topic in here. Then we are going to solve the first example. Okay. The example number 1. What is the example 1 about? We are going to read it, okay? We need to solve inequalities that involve addition. Solve inequalities that involve addition. Then we are going to read the problem, okay? On the airline that Raul is using, the weight limit for both suitcases combined is 50 pounds. So we need to determine how much can Raul's second bag weigh without going over the limit, okay? So the limit that we are going to have for the weight is 50 pounds. He already has a bag that has a weight of 38 pounds. You can see it in the picture that you have at the right. Okay. So reasoning, you have one question. Is there more than one possible ways for Raul's second bag? This is an inequality, guys. So yes, this is going to be more. They are going to be more than one value, okay? For the weight that Raul can have, okay, in the second bag. Because when we have an equation, for example, you obtain only one value. Something equal, the variable equal one value. In this case, the variable is going to be in an okay, in interval, okay? It's going to be between many values. So you can have more than one solution for the second weight of the bag. So we need to write an inequality to represent the situation. Then we are going to solve the inequality to find the weight of the second bag, P. Okay, so for the variable P, we are representing the second bag. So the weight of the first bag, the weight of first bag plus the weight of the second bag is going to be less than or equal to the baggage weight limit. I'm just going to expand this so you can see it better. Okay, for the first one we have this. And what is the inequality that we have? The weight of the first bag is going to be 38 pounds, right? Plus the weight of the second bag, that we don't know the weight of the second bag, but we know that we are using the variable P. Okay, this is going to be less than or equal to the baggage weight limit. Okay, so what is the weight limit? 50 pounds. In this case, okay, we know that the limit that we are going to have are 50 pounds. Then what else can we do in here? If I pass the 38 that is in addition, I pass it to subtract, remember, okay? I can have the interval for the variable P. So P could have less than or equal to 50 minus 38. So P is less than or equal to 50 minus 38. Okay, the symbols that you have in the book, that is this one, okay, with a line below is the equal, only that I cannot write the symbol, I don't have it in my keyboard, so I use both of them. I use less than and equal to, okay? What is the same symbol that you have? I'm representing the same symbol that you have on the book, okay? So then what else we can do? B is going to be then less than or equal to the result for this, that is going to be 12. Okay. So what can we say about this? In here, we use the inverse relationship between addition and subtraction to isolate the variable. Isolate the variable is that you have it alone, so you can determine the interval. And the subtraction property of inequality is like subtracting property of equality. So this is about what I was telling you at the beginning, that the inequalities you are going to solve it in the same way that you solve the equations, okay? Only that the symbol is different. When we have a equation, it's only equal. But in here we have less than or equal to, we can have greater than or equal to, we can have the symbols alone like this, okay? So this is the only thing that you need to remember about. Later, we use a number line to show all the possible solutions to be less than or equal to 12. If the second bag weighs 10 pounds, the total weight is 38, that is the first one, plus 10 equals 48. This is going to be less than or equal to 12. So what are they trying to explain to you in this theory that they write? That you can have more than one value, you can have different values for the weight of the second bag, okay? So it's not an exact value. It's going to be an interval of values that it could be, for example, the second bag, 8 pounds, 9 pounds, 10, 11, 12 pounds, okay? But the limit is 10, so you cannot have more than 10. And as you can see in the 12, when they represent it on the number line, the point is completely colored, okay? The point that appears in the 12, okay? It's for this symbol, okay? Less than or equal to. If we don't include the equal, that symbol is going to be open, but in here it's closed for the equal symbol. So I'm going to write the answer that you have in here. Raul's second bag must weight 12 pounds or less to avoid going over the weight limit for both suitcases combined. Okay. Now we have one below that is going to be very similar. We have the other exercise that says try it. We have, okay, Kyoko has completed 26 hours of community service. Her goal is to complete at least 90 hours. 90 hours in the semester, okay? So we need to write and solve an inequality to show how many hours each Kyoko needs to complete to meet her goal. Use the number line to graph the solutions, okay? Convince me. They ask you, is there more than one solution to the problem about Kyoko? If it's an inequality, we already know that yes, it's more than one solution, okay? We can give one value that is a solution and one value that is not a solution. So we have this age plus, I have many spaces in here in blank, okay? So in here I'm going to complete. Age plus what? What I'm going to add in here? I'm going to add the 26 hours that she already completed. So age plus 26, and it's going to be, what symbol can we use? Less than or equal to, greater than or equal to. I'm going to use greater than because read that her goal is to complete at least 90 hours. So the less that you can have is 90, but you can have more than 90. Okay, so you can have more than 90 or equal 90. So this is the part that you need to understand about the symbols. Okay, don't confuse where are you going to place less than, or where are you going to write the greater than. Okay, I'm going to move this to appear on the center. Then age plus 26 is going to be greater than or equal to 90. What is going to happen with the 26 that is in addition with age? Then I'm going to pass it to subtracting the other side. So age is going to be greater than or equal to 90 minus 26. What is the result for 90 minus 26? We have the result that age is going to be greater than or equal 64. Okay, so in the number line that you have, you can see that they start in 60, 65, 70, 75, 80, 85, and 90. So she can complete more than 64 hours. If it's greater than or equal to, it means that it's going to the right. So starting in 64 and to the right, you can say that she can complete that number of hours, okay? This is the first interval. She can complete more than 64. And 64 or less is the interval that she cannot complete, okay? Because if she obtained less than 64, is not going to complete her goal. That is going to have more than 90 hours. So in this case, we solve the inequalities using addition. The other example is using subtraction, but it's going to be very similar. Okay, now we are going to continue with the example number 2, that is to solve inequalities that involve subtraction. That involve subtraction. Then we are going to read the problem. We have that the weather forecast predicted that the evening temperature could get as low as negative 12.5 Fahrenheit degrees. Between afternoon and evening, the temperature dropped by 7.5 Fahrenheit degrees, which was consistent with the forecast. What could be the afternoon temperature? T. Have been, okay? We are going to use the variable T to the temperature. So we need to write in inequality to represent the situation. Then we solve this inequality to find the result, okay, for the inequality. We solve it like you solve a equation, okay? We solve it in the same way. Remember only that the symbol is different. We don't have only the equal, we have greater than or equal, less than or equal, or only less or the other greater than, okay? Less than or greater than. So we have this equation. T is the temperature minus 7.5 Fahrenheit degrees that the temperature dropped. This is going to be greater than or equal to negative 12.5. This is what you have on the image, the law of negative 12.5 Fahrenheit degrees, okay? So you can see how easy it is, guys. You only need to move, okay? The 7.5 that is in subtraction, you can pass to add to the other side. So T is going to be greater than or equal to negative 12.5 plus 7.5. So you can see that it's the same that we have in the equations, only that we copied these symbols for the inequalities. Then you solve and you obtain the result, that is negative 12.5 plus 7.5 is going to be negative 5. Then if we represent it on the number line, we can say that the afternoon temperature could have been negative 5 or warmer, okay? So negative 5 or warmer. I'm not giving only one value for the temperature. I'm not giving only one value when we have an inequality. When it's in an inequality, the value is in interval, okay? So we have more than one value. In this case, I can have negative 5, negative 4, negative 3, negative 2, negative 3.5, negative 4.5, okay, etc. I can have different values for this. Then we only need to solve the last example, that is the number 3. If you don't have any question about the number 2, I can see that for this topic, okay, you are understanding better. It's very similar to the equation, so I understand that maybe that's the reason why you understand it well. The only thing that you need to be careful with is with these symbols, with this, okay, not too confusing. In the example 3 now, we need to isolate the variable, okay, for the inequality that they give you. That is, okay, solve more inequalities in the number 3. Solve more inequalities. I'm sorry, this is what I mistake, okay. Then we have x minus 1/2. This is going to be less than -2/3. And what else can we have in here? Okay. We need to graph the solution later, but we already have the graph, okay, in here, so I explained you the graph. What is the only step that you need to do to complete this, guys? X minus 1/2. So 1/2 is going to pass to the other side to add because I want to have my variable alone. I don't want x with other value. So x is going to be less than -2/3 plus 1/2, 1/2, okay? Remember to isolate the variable because it's the interval that we want to find. In this case, you can see that we don't have the equal. We only have less than, because the value that we obtain only has to be less than the value that we are going to obtain, okay? So x is going to be less than -1/6. So in the graph that you have, you can see that -1, -2/3, -1/3, and in -1/6 we have this circle, okay? But it's not colored, it's empty. This is due to this symbol, okay? When we have only this, less than, or only the other one, only this, we don't color the circle that appears on the number line, okay? Because it means that you don't include all the numbers. You are including only the numbers that are less than -1/6. So I don't include even this, okay? I'm just taking the values that are less than -1/6. I don't include all the others, okay? And obviously the values that are greater than this one are not included neither, okay? So you solve the inequality using subtractions, and you already have the graph. We only explained the graph, and this is that's all about this exercise number 3. So for today, guys, I'm going to finish the recording of this class. Okay, I'm going to finish this video, and later we continue talking.